Let's use the fundamental theorem of calculus to find the derivative of a function with variables as limits of integration. Notice that our integral has variables in both the lower and upper limits of the integral. So we first need to split this up into a sum of two integrals. The first integral will have limits from x to 0, and the second integral will have limits from 0 to x squared. Recall that to find the derivative of a function defined as an integral, the lower limit must be a constant and the upper limit must be in terms of x. One property of integrals states that if we switch the limits of integration on an integral and make the integral negative, we do not change the value of the integral. So let's do that on the first term. Now to find f prime, we must differentiate each term. Using the fundamental theorem of calculus, we can differentiate the first term by substituting x for t. So, the derivative of the first term is negative 3x squared. Finding the derivative of the second term is a little more tricky. We have to apply the chain rule. Let's let u of x equal x squared. Then we substitute u of x for x squared when finding the derivative. Substituting u of x for t and applying the chain rule, we get 3 times u of x squared times du dx. Now substitute in x squared for u of x and square it to get 3 times x to the fourth d dx. The derivative of x to the fourth is 4x cubed. So, simplifying, we get 12x cubed. Remember that the sum rule for derivatives states that the derivative of a sum is equal to the sum of the derivatives. So we find the f prime is equal to the derivative of the first term plus the derivative of the second term. Using direct substitution, we get negative 3x squared plus 12x cubed. Therefore, the derivative of f is equal to negative 3x squared plus 12x cubed.